All right, everybody. So today we finished up our virtual lab. So if I come here, you got to come back here to Wednesday. Click on this scientific method virtual lab. Go ahead and click on that. And so I know a lot of us are having problems with this Adobe Flash Player here. Okay, let me get this pulled up here. So if you are having problems with that, a lot of the times it says it's blocked or something. So if you come up here to your web address or your address bar here, there will be like a little puzzle piece and it's got a red X on it. You'll click on that red X and then you just click your settings, or you go to manage settings, something along those lines, and you'll just click allow Adobe Flash Player to run or something like that. And then you'll come to something like that, and then you'll come back to this page right here, and it'll say click to enable Adobe Flash Player. So I'll click, and then I'll say something like allow. So it looks like this. I try to use Google as much as I can. I don't have Google on this one, but it brings you up to this page. Okay, and so what we're doing here is, if you guys have read through your that paragraph, it starts talking about light and light absorption and heat absorption, and it tells you that black absorbs more light than any of the other ones, and so it kind of gives you a foundation to build your hypothesis on. Should one of those colors, like black, blue, green, yellow, or white, be a color that absorbs the most heat? Okay, and so this is what we're testing here. Well, black, well, blue absorb the most heat, and then I click test here, and then our timer starts running. Okay, and after 5 minutes, it comes up with 3 different temperatures for black and 3 different temperatures for blue. And you'll do this for green and yellow and white, and then you'll go on to nylon, you'll go on to denim. Anyway, so now I'm in denim, and so your table has wool, and then it has a column for nylon, and then it has a color for denim. Okay. You'll go ahead and record all these, but you're going to record their averages. Okay. And so on my computer, I use a computer calculator. Let's see, where's my calculator? Right here. Okay. And so I'm able to have to shoo my window over here a little more. But I'll go ahead and run this test here. And so I'll add these 3 up, and then I'll divide by 3. Okay. So I have 29.5, 29.8, 29.4, 29.5 plus, I click on this guy, 29.5 plus 29.8 plus 29.4 equals, all right, and now this is the number right here that I'll divide by 3, okay? And so my number now for black denim is 29.6, okay? So I want you guys to round to the nearest 10th place. So this is the 10th place right here. So it should be 29.6, okay? And you will do that for every single box. So this is the one for the black denim. And so you're going to do that same exact process for every single cell in that table, okay? So then, once you get all of those filled out, you get that table completely filled out, and they're all about in the, I think the highest one is like 30.8, and then the lower ones could be as low as 24. So if you're getting anything below 24, getting anything above 30.8, you may want to recheck that. You may want to recheck those numbers, okay? And so we're going to walk over here to my whiteboard, okay? And we made a graph today on the whiteboard. So let's blow this guy all the way up. And we made a graph with all of the numbers, all of the averages that we found today. Okay. And so today we focused again on making graphs. Okay, so I know you guys can't see the green very well off my whiteboard, but it says heat absorbed by color is the name of the title of this graph. Okay, so again, we have our y-axis right here, and we know that the dependent variable belongs on the y-axis, okay? Our dependent variable in this experiment is our temperature. We measured our temperature in degrees Celsius. Okay? So our temperature depends, right? It's our dependent variable. It depends on the color of the material. So I have my independent variables. So independent variables are the ones that the experimenters, the scientists set. Okay, so we determine the colors and we determine the materials here. And so I also have a key up here. So I put black, blue, green, yellow, white, but then I had a key up here for nylon, wool, and denim because this key is to help us differentiate between this bar right here is our red is denim. So this bar right here represents denim. Green is wool. So I have wool right here. If you can see that, it's the clear one you really can't see. And then I have purple here, which is our nylon one. So I can see that for my key. Okay? And so since the greatest number on your table is 30.8, we chose a number that was the top number on our graph here was 35. We chose 35 because it's a good number. It's easily divisible by 5. And so what I did was you need to make your own graph based off of the table that you made. Okay, so there's 3 bars per color, right? Because you're going to test black nylon, black denim, and black wool. And then you're going to do the same for blue, the same for green, the same for yellow, the same for white. And you're going to graph all 3 of them, okay, the same exact way. All right? And so you'll want to write this down like on a nice loose leaf piece of paper where your increments are nice and evened out. So I went 5, 10, 15, 20, 25, 30, 35. For me, I used a nice meter stick and I did every 10 centimeters was my increment. Okay? Let's see. And so I think that's all I have for that for your virtual lab. That virtual lab needs to get done. If you're having any troubles doing that, you're getting it set up, please email me, get a hold of me so we can get this figured out. Okay? All right, so the next thing we did. So I'm going to go ahead and run back to my plan book page. Oh, let's go to plan book here. I'm going to log in. And so today we worked on identifying variables and writing a hypothesis attachment. Okay, so it says identifying variables and the hypothesis. We actually didn't get to reading 2 scientific articles today. The computer took way longer than I thought it would, so I apologize for that. We actually haven't got to these 2 scientific variable worksheets yet, but I really wanted to get to these variable worksheets. So today it wasn't due for a grade. We just got to the first question. We did it together. So I'll go ahead and do the first question with you guys. And so you guys you can, if you print these out or if you do them online, you can do either or. It's fine with me. But let's see if I can get a markup on here. Sometimes you're able to. Anywho. I'd like to get some ink on here. Anyways, I'm not going to be able to mark this up for you, but it says underline the independent variable, okay, and it says circle the dependent variable and then list 3 constants and control. So right here in this box, it gives you a nice definition of what are independent and dependent. We've already gone over this, right? And so we're going to come down here, and I'm going to go ahead and look at number 1, and this is the only one we did today. So how does the distance from an eye chart affect the number of letters that are recognized on a line? Okay, so what's first? What's our independent variable? Well, it's the one that the experimenter changes. So how does the distance from an eye chart affect the number of letters that are recognized on a line. So in this instance, so I'm going to come up here and I'm actually going to underline distance from eye chart, because if you can imagine, if you're at a doctor's appointment or something like that, the doctor will say, all right, stand 5 feet away, stand 10 feet away, stand 15 feet away from this eye chart. And right, so he in that case is that scientist. He's the one that's changing it, or he's the experimenter. He's the one that's changing that variable. Okay, so I'll go ahead and underline that guy. And then you need to circle the dependent variable. So what will change based on the distance from the eye chart? Well, it'll be the number of letters that are recognized. Okay, so the number of letters that are recognized. I'm going to go ahead and just highlight those. And if that works better, I think that's fine. Maybe I should have changed it to highlight. That'll probably work best. Okay, so what are some constants and controls? Well, I talked to the other classes about our one with the color lab and heat absorption. Well, if you notice that there's a 60-watt light bulb that's used every time, it's the same power of light bulb that's used, and on top of that, the timer is the same. So you want to keep the timer, and it was 5 minutes, and they kept it at 5 minutes every time. And you want to do that, right? You want to keep those variables the exact same every time you run this experiment. Okay, so in this experiment, what's something that would stay the same? Let's talk about maybe the eye chart, right? You don't want to change an eye chart from person to person and use some small font and some big font, right? So let's just say eye chart. Okay, and as you guys manipulate some of these, it starts getting all wonky and it pushes the page down. I just do this and I backspace. That's all I'm doing, is I'm backspacing this underline. So there's the eye chart, and what else? How about the person, right? You don't want me reading at 5 feet and then take me out and then have somebody else read at 10 feet, right? You would have me stay in the experiment the whole time, going from 5 feet to 10 feet to 15 to 20 to however far you go. And then, the type of light, you want to make sure it's in a lit place or a dim place. You don't want to change the lighting or the angle and stuff like that. And you can kind of go on and on with the constants and controls, but you want to try to keep everything the exact same way, except for your dependent and your independence. Okay. So your hypothesis. So what would be a good hypothesis for this? And this is the one that we used in class and we like to start out with if and then statements for our hypothesis. And a hypothesis is not a question, it is a statement. Okay, so if we are farther from the chart, then we will recognize fewer letters on a line. Okay, and again, like I said, we can take this backspace, keep on backspacing. Maybe we can get it all in one line. No? Okay, and that's fine. And if it does that, that's totally fine. Maybe I can do this. I can just underline like that. Okay, and so there's your hypothesis. Okay, if we are farther away from the chart, then we will recognize fewer letters on the line. And realize that I use recognize because recognize, so I use the same verbiage in my sentence, in my hypothesis, as I do in the question or the statement that they're presenting to me. Okay, so that's something important that you guys need to start learning to do, is as somebody asks you a question, you need to restate the question, and we're doing the hypothesis, so we're restating the question in a statement format. Okay, so again, this is not homework, this identifying variables worksheet. I will have it due sometime, so I guess it's not due quite yet. Or did I think I did assign it to you guys on Teams. I can't remember if I assigned this or the scientific articles lab. Either way, we're doing this in class on Wednesday. Okay, if you guys can get that done and you want to turn it in today, that'd be fantastic. If not, I'm going to have you guys turn it in on Wednesday with everybody else. But now that you guys have this video, you guys can more than welcome turn it in. But go ahead and make sure you get email me if you guys need any help, if this video helped you, if there's still some questions that were confusing, if you're not able to do that lab still, just get a hold of me. Other than that, have a great weekend, guys.